section 10.5. We're looking at additional relationships with lines in our circle and the arcs that they make. So our essential question, when a chord intersects a tangent line or another chord, what relationship exists among the angles and arcs formed? Okay, and that's a little simplistic. We actually deal a little bit with secants here as well. But the idea is that we're looking at lines intersecting in our circle and the relationship with the arcs. So our first one, tangent and intersected chord theorem, says if a tangent and a chord intersect at a point on a circle, then the measure of each arc formed is half the measure of its intercepted arc. This is basically the same thing we looked at in 10.4. The difference is it's not chords, right? So it looks a little bit different. So here we have these two lines that meet, making these two angles, right? Angle 1 is half of arc AB. Angle 2 is half of arc ACB. Okay. What we looked at the other day, you had them staying within, but it's still on the circle, it's still cutting in half. So when we look at example 1, they asked me for angle 1. So I have 132 here. I cut that in half, and angle 1 is 66. Okay. In B, they ask us for EFD. So we're doubling that. So that is 220. And again, watch. People get confused here because they cut in half when they should double. They double when they should cut in half. The angle is always half the arc. So I'm doubling to get to my arc. Okay. Also, you could use this to find other parts. I know this. So if I subtract this from 180, or I'm sorry, from 360, I have this arc over here. The 110, if I subtract from 180 because of the straight line, I have that angle there. So you can have problems that involve that. Okay. Then the next thing here is looking at our other angle relationships. Okay, so on the circle is what we just did. All right, it is half the arc. Right. Inside the circle is our next theorem, the angles inside the circle theorem, which says if two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the intercepted arcs. Right? So we add the arcs, and divide by 2. Right? And I'm showing it here. They show it this way here. Okay, that's what we'll look at on these next two examples. Our third thing, and this is the first theorem on the top, is when we're outside the circle. Okay, when we're outside the circle, we're going to subtract the arcs and then divide by 2. Okay, so on the circle, we cut in half. Inside, we add and divide by 2. Outside, we subtract and divide by 2. So, example 2, okay, we looking for x. They give me these two arcs, so I add them, 112 plus 140, and divide that by 2. Okay, so I get 252 over 2, which is that x is 126. Okay. Now, depending on what we're doing, we can make this more complicated. So example 3, we do that, right? We have 95 in y and 102. All right. So first, the angle I care about is one of the two angles in here, all right, which are vertical angles. So they're always going to be the same, right? That's why I use up here, where the x is doesn't matter here, one of these two, right? So that's what I want. So to get that angle, I do 180 minus 102, all right, and I get 78 there as that angle, right? So then my setup here, we have 78 That's my angle. That's equal to my arcs added up divided by 2. So I multiply both sides by 2 to get rid of that 2 in the denominator. I get 156 equals y plus 95. Subtract the 95, and y is 61. Okay. And going back to this, part of the reason we need this here, when we had the central angles, they were just equal. As I move away from the center, the angles here are going to stay the same as themselves, but the arcs are going to be different, and that's why we need to do this addition. Then, looking at angles outside the circle, right? I mentioned this on the front with that thing that we had there where we wrote them all down. If a tangent and a secant, two tangents or two secants intersect outside a circle, right? Basically just means anything that intersects outside of a circle and touches, both lines touch our circle, then the measure of the angle formed is half the difference of the measures of the intercepted arc. Okay, so there's 3 different ways this can look, basically, giving us a different number of angles or a different number of arcs. So the tangent and the secant would be this one. We have 3 arcs total. Right? The 2 tangents would be this one. We have 2 arcs total. And the 2 secants would be this. We have 4 arcs total. In all of those, we're subtracting the arcs. So we're subtracting the smaller arc from the larger arc and dividing by 2. All right, so I subtract this from that, divide by 2. Subtract this from that, divide by 2. All right. The more arcs they have, the more information you need to be given. If we have something like this, I can give you one piece of information and we can find it. Here, basically, I need to give you the right information or additional stuff to find that. So example 4, they give me exactly what I need. Right? X is 170 minus 72. Divide that by 2. All right, so 170 minus 72 gives me 98. 98 divided by 2. That my X is 49. Right. We can also find arcs with this, which is what we're looking at B. Right. We have 29, which is my arc, equals 114 minus X over 2. All right. I'm subtracting the X because it's the smaller one there. All right. So when I multiply by 2, I get 58 equals 114 minus X. Subtract the 114 from both sides. I get negative 56 equals negative X. The negatives cancel, so 56 is equal to X. Okay. The last problem is actually one that normally confuses people. All right, I'm looking for X, and they give me the 100. Right, so that's the smaller angle. That's what I'm subtracting. What messes people up is they don't normally give me the other thing I'm subtracting from here because I have tangent lines. My full circle is 360. So they give me this as 100. 360 minus that 100 gives me the other part here. I think part of the confusion is people subtract 360 from 100 and then they just want to deal with that because they already did the subtraction. But that's not what that's the number I'm putting out in front here. Or depending on where they give me an angle, maybe the number I'm putting in back. But it's not my final subtraction. So then 260 minus 100 gives me 160. So I have 160 over 2, and my X is 80. Okay, and then example 7. Right? Combining everything we have here. So first one, we're on the circle. So our angle is half the arc. So I ask for ACB. I just double that and get 240. Right? B, I'm looking for the arc. They give me 26, which is outside the circle, so I'm subtracting. So if y minus 30 over 2, multiply by 2, 52 equals y minus 30. add that 30, and my y is 82. C, right? C is another one that messes people up here. They give me an angle of 60. Okay, my arc, if I, depending on which one I label, I'm going to label this as X. Okay, so then X is my smaller one, right? And then my other thing is 360 minus X. That's this one out here. So when I'm going to multiply both sides by 2, so I get 120. I have 360 minus X, which is minus 2X. Subtract the 360, so I have 240, actually a negative 240 equals negative 2X. So my X is 120. All right, so realize when they give you that variable, or when they give you the angle here, you have X and 360 minus X as your two things. All right. And actually, what are they asking me for here? They don't label what they're asking for. If they're asking for one of these arcs, I would have to think about that and probably make that X. All right, they don't actually label that here. All right, so we'll say we're solving for that X. All right. And then D, similar to what I looked at before, the 52 is a little confusing. They give it to me in the wrong spot because of the arrow, though it looks originally like it is in the right spot. So I have 180 minus 52 gets me 128. I'm now inside, so that's equal to X plus 144 over 2. Right? Double the 128. So I get 256 equals X plus 144. Subtract the 144, and we get that X is 112. Okay. So there's a couple tricks in there, but the key thing is these three concepts here that are, if I'm on the circle, the angle is half the arc. If I'm inside, I add the two arcs and divide by 2. And if I'm outside, I subtract the two arcs and divide by 2.